Welcome to a webcast produced by the Learning Enhancement team based in the Dean of Students office at the University of East Anglia. This webcast is part of the Steps into Algebra series and concerns solving quadratic equations using the quadratic formula. This guide looks at quadratic equations and gives a method for their solution using the quadratic formula. The solutions are described graphically as particular points on the corresponding quadratic function. Introduction. Before reading this guide, it is recommended that you read the study guide Quadratic Functions to familiarise yourself with some of the terms used here. Every quadratic function takes the form y equals ax squared plus bx plus c. This equation is known as the general form of the quadratic function. When you solve a quadratic equation, what you are doing is finding the points where the quadratic function crosses the x-axis. At every point on the x-axis, y takes a value of 0. This is a crucial fact. By setting y equal to 0 in the general quadratic function above, you get the general quadratic equation. Ax squared plus bx plus c equals 0. The solutions of this equation give the points at which the graph of the corresponding quadratic function crosses the x-axis. In mathematics, the solutions have a special name, and they are known as the roots of the equation. There are a variety of methods for solving quadratic equations. See study guides, Solving Quadratic Equations by Factorisation, and Completing the Square. This guide concerns the most common technique for solving quadratic equations, using the quadratic formula. The quadratic formula. If you have to solve a quadratic equation, you can use the quadratic formula to find the values of x. X equals minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. You must identify the values of a, b and c in your particular quadratic equation, substitute them into the quadratic formula and perform the resulting calculation. You can solve every quadratic equation and hence find the roots directly by using the formula above. However, the calculation can be complicated. If you can factorise the quadratic expression, then solving by factorisation is quicker and easier than using the formula. However, some algebraic manipulation is involved. You should certainly use the quadratic formula when you cannot work out the factorised form of the quadratic expression, and it is especially useful when the value of a is not 1. Let's do an example. Find the roots of minus x squared plus 3x plus 2 equals 0. To solve this question using the formula, you must determine the values of a, b and c and substitute them into the quadratic formula. To do this, try writing the quadratic equation you are interested in under the general quadratic equation, like so, and then draw boxes around the corresponding values. Can you see that a equals minus 1, b equals plus 3, and c equals plus 2? It is important to include the signs to help you see whether a, b or c are negative. When you have found a, b and c, you substitute them into the quadratic formula using brackets to help you. Do not try to do the calculation all at once, as you could make a mistake. For this example, the first stage is to substitute a equals minus 1, b equals plus 3 and c equals plus 2 into the quadratic formula, which gives this. Next, use Bodbus to remove the brackets. Minus plus 3 gives minus 3. Plus 3 squared is 9. Minus 4 times minus 1 times plus 2 is plus 8, and 2 times minus 1 is minus 2. Finally, add 9 and 8 to give 17 underneath the square root sign. When you get to this stage, the plus minus symbol plays an important role. You have to choose either plus or minus. Each choice gives a separate answer, which are your two roots. At the moment, x equals minus 3 plus or minus the square root of 17, all divided by minus 2. If you choose plus, you get x equals minus 3 plus root 17 divided by minus 2, which equals minus 0.561. If you choose minus, you get x equals minus 3 minus 17, all divided by minus 2, which equals 3.561. So your two roots are 3.561 and minus 0.561. The roots also tell you that the corresponding quadratic function y equals minus x squared plus 3x plus 2 crosses the x-axis at x equals minus 0.561 and x equals 3.561, as shown in the graph below. The discriminant. Part of the quadratic formula is an interesting piece of mathematics called the discriminant. Specifically, the discriminant is the piece of mathematics underneath the square root symbol, b squared minus 4ac. The value of the discriminant for a given quadratic equation gives you information about the form of the corresponding quadratic function. If you need to sketch a quadratic function, calculating the discriminant can save you time and effort. There are three specific types of discriminant. 1. If b squared is greater than 4ac. If the value of b squared is larger than that of 4ac, then the value of the discriminant is positive. This means that you have a positive number under the square root sign and, due to the plus minus symbol in the quadratic formula, you have to choose either plus or minus. This gives two real roots, indicating that the corresponding quadratic function intersects the x-axis in two places. 2. If b squared equals 4ac. If the value of b squared is equal to that of 4ac, then the value of the discriminant is 0. This gives you 0 under the square root sign in the quadratic formula. As the square root of 0 equals 0, the plus minus symbol in the quadratic formula plays no further part in the calculation, as you are adding or subtracting 0. This means that you have one real root at minus b divided by 2a. This means that the corresponding quadratic function just touches the x-axis in a single place. 3. If b squared is less than 4ac. If the value of b squared is smaller than that of 4ac, then the value of the discriminant is negative. This gives you a negative number under the square root sign. The square root of a negative number is not a real number. It is called a complex number. The plus minus symbol in the quadratic formula means you still have two roots, but they are complex numbers. Complex numbers cannot be shown on a conventional graph, and this means that corresponding quadratic functions never cut the x-axis. When you are beginning to study mathematics, you will almost certainly be given examples of quadratic equations with discriminants that are either positive or 0. A quick calculation of the discriminant can help you determine the shape of quadratic function you are investigating. This can help you decide whether the answers you get are reasonable or not. Further guidance and information. If you have any further questions about algebra or would like to discuss any other aspects of mathematics, you can talk to your lecturer or personal advisor. or make an appointment to see a Learning Enhancement tutor in the Dean of Students office. You can telephone 01603 592761, email dos.help@uea.ac.uk, or visit our website at www.uea.ac.uk/dos/let. There are further resources on many other aspects of numeracy, mathematics, statistics and science available from the Dean of Students office and on its website. These include questions to practice, model solutions and webcasts illustrating essential skills. This guidance is one of a series on mathematics produced by the Dean of Students office at the University of East Anglia.